Welcome to the deep dive. Today, we're jumping straight into AI agents.
That's right. These programs that sort of perceive their environment, make choices.
And take actions to reach a goal. We hear about AI constantly, but we want to look at a part that's, well, more accessible.
Exactly, the kind of finding their way into daily life. And our main source today is the book AI Agent Applications.
Ah,
It's a
yes.
really good guide, especially for understanding agents that aren't super complex, stuff anyone can grasp, maybe even build. And you can find it easily on Amazon.
Perfect.
Mm-hmm.
So our goal is clear.
Mm-hmm.
Understand these simpler AI agents, what they are, how they tick, where they pop up without the heavy jargon. Think of it as a shortcut.
A fast track. So we'll cover what makes them easy to develop.
Their main features, how they work,
Examples, some project ideas, tools.
and yeah, the ethical side too, even for simple ones. Okay, let's start there. What makes an agent easy to develop?
Well, it's interesting. The book AI Agent Applications makes a great point here. It's not just about less coding. It's more about the core simplicity. Can you easily understand what it's trying to do and how it does it?
Okay, conceptual simplicity.
Right. And fewer resources needed, less of your time, maybe less money, definitely less raw computing power.
Mm-hmm.
And crucially, they focus on clear, manageable tasks, not trying to boil the ocean, you
Well,
know.
keep it contained. That makes sense for getting started.
Exactly. The book really hammers this home set realistic goals initially. Focus is key.
Okay, simple, targeted. So what are the key characteristics then? What defines these easier agents?
Well, according to AI agent applications, they usually have a very specific, limited job, maybe just one small thing or two.
Tight scope,
Yeah. Makes them easier to build, easier to understand, and often they run on fixed rules, rule-based systems.
like a flowchart.
Pretty much. Like if this specific thing happens, then do that specific action. They don't usually need to learn from tons of data.
Ah, okay. No big machine learning models needed.
Generally, no, not for the really simple ones, which means less need for powerful hardware. And because it's rule-based, their behavior is predictable, easier to fix if something's off.
Right, you can trace the logic. If this, then that. What about the data they use?
Good question. The book mentions it's usually minimal or simple data,
Like what?
like direct user input you typing into a chatbot, or maybe reading a basic sensor like a button click, or even just reading simple files.
Okay.
Building them often involves basic scripting, maybe some Python, using that straightforward if-then logic.
And you mentioned tools earlier.
Yeah,
Some that don't need much code.
absolutely. AI agent applications highlights these no-code or low-code platforms. They let you build visually using pre-made blocks.
Drag and drop.
Sort of, yeah. They mention reactive agents, specifically ones that just react instantly to what's happening now. No memory, no big plans.
Like a reflex action.
Huh?
Okay, so summing up, easy to develop means understandable tasks, simpler tools, no complex AI theory or massive data sets needed.
Exactly. And the best starting projects, things you can easily imagine and build without needing a PhD in AI or a supercomputer.
Got it. So how do they actually work? You mentioned sense, decide, act.
Right, the classic cycle. AI agent applications breaks it down really well for these simple agents. First is perception sensing the world around them.
How do they sense?
For simple agents, it could be really basic. User input, like we said, chatbot text, button clicks,
Uh-huh.
or reading simple data, a text file, a CSV spreadsheet with, say, product names and prices, or maybe calling a basic web service and API to get the weather or a stock price.
Simple data in.
Yeah, and the key, as the book notes, is the data is usually clean, straightforward, no heavy processing needed just to understand it.
Okay, so it senses something simple. Then the decide part, the thinking.
Right. For these agents, it's almost always those clear rules we talked about, rule-based systems.
Give me an example.
Like, if the temperature reading is above 30 degrees Celsius, then activate the turn on fan action. Or, for a really simple game, the book mentions using something like the Minimax algorithm, just a basic way to choose the best move in, say, tic-tac-toe.
Okay.
If there's any planning, it's usually a very short, predefined sequence of steps, nothing too elaborate.
Simple rules, simple logic, check. And the final step,
Yeah.
act. What do they do?
The actions are usually direct, easy to observe. Showing a message on screen, sending an email.
Ah, like a notification.
Exactly. Or maybe updating a value in a file. Or changing a setting in the program itself. We're not usually talking about controlling physical robots or complex machinery here.
It's all very transparent. Simple input, clear rule, obvious action.
Precisely. And AI agent applications makes a really important distinction here. Complex AI, like deep learning, can sometimes feel like a black box. Hard to know why it made a certain decision.
Yeah, I've heard that.
But with these simple agents, it's clear. You can follow the input, see which rule fired, and understand the resulting action. That transparency is gold for beginners. Helps you learn step by step.
That makes a huge difference for learning, definitely. Okay, we focused on simple. How do they stack up against the more complex AI agents?
AI agent applications gives a good compare and contrast. One big area is autonomy, how much they think for themselves.
Right.
Simple agents mostly follow their script or react. Complex agents can plan ahead, learn, adapt, make decisions without being told exactly what to do.
So like a basic bot versus a smart assistant versus something
Right.
more.
Kind of. Bot follows the script. Assistant makes some choices. A really advanced agent adapts and acts truly independently.
Okay, what about the jobs they do?
Simple ones are great for those small, repetitive, well-defined tasks, like sorting email. Complex ones tackle bigger, messier problems, things that need judgment or creativity.
In learning, you said simple ones don't really learn.
Generally, no. Their rules are fixed. Complex agents often use machine learning or reinforcement learning to get better over time based on data or experience.
Environment matters too, I guess.
Big time. Simple agents prefer predictable, stable environments. Everything is known. Complex agents can often handle dynamic situations, incomplete information, maybe even opponents trying to trick them, like in a complex game.
And the decision-making itself.
Simple uses basic rules, maybe simple algorithms like minimax. Complex uses advanced stuff, deep neural networks, probabilistic reasoning, much more sophisticated techniques.
So there's a clear trade-off. Easier development also means less. Raw intelligence,
Sure.
especially learning and independence.
That's the gist of it. The book points out that while AI agent is a broad term, many beginner-friendly projects are closer to bots or basic assistants than fully autonomous, intelligent agents. Simpler build, simpler capabilities.
Okay, that framework is helpful. Let's ground this with some real-world examples. What kind of easily developed agents does AI agent applications talk about?
It gives some great ones. One category is simple automation bots, just programs following rules for repetitive stuff.
Like what?
Think of an automated email sorter. It reads the subject, maybe the sender, and applies rules. If subject contains invoice, then move to finances folder.
I use filters like that in my email.
Exactly. And often you can set those up right in Gmail or Outlook using their built-in rules. No complex AI learning needed, but it automates a task. Feels smart.
It does save time. What else?
Another example is a basic web scraper for price tracking.
Ah, we mentioned that conceptually.
Right. This bot goes to a specific product page, finds the price, maybe by looking for a particular bit of HTML code where the price usually sits.
Okay.
Checks if it's dropped below your target, and maybe emails you. It works because websites often have predictable structures, and tools like Python's Beautiful Soup or Scrapey help you pull out just that piece of data. No need for the AI to understand the whole page.
So they automate human clicking and checking, basically.
Pretty much. And the book highlights these as great ways to understand agent design sense. Find the price, decide, compare to target, act, send notification, and you see the value of automation.
Makes sense. What other categories?
Rule-based chatbots are another big one. Following scripts for simple conversations, FAQs, basic support.
The little help windows on websites?
Often, yes. AI agent applications mentions FAQ bots matching keywords in your question to a list of pre-written answers. Or basic support bots for specific tasks, like check my balance, using fixed commands and responses.
Why are they simple to build?
They rely heavily on pattern matching. Does the user's message contain balance or order status? The responses are scripted. Tools like Python's NLTK library have modules for this, or you can use no-code chatbot platforms.
I've definitely run into chatbots that get confused if I phrase things weirdly.
Exact. That's a key limitation, and actually AI agent applications points this out as a learning opportunity. They don't understand language deeply. Unexpected phrasing throws them off. And managing hundreds of rules can get messy. But these limits show why we need more advanced AI for better language understanding. Starting with rules teaches you the fundamentals.
Good point. Okay, one more example.
The book also talks about conceptual smart device agents built entirely in software, simulating a smart light or thermostat.
No actual hardware.
None needed. You could code a rule like, if simulated time equals a 19.00, virtual light equals ON, or a thermostat If simulated temp, target temp, virtual heater equals ON.
Ah, so you focus just on the control logic.
Precisely. It's great for learning because you skip the hardware setup, the wiring, the sensors. You just focus on how does
Mhm.
the agent sense its simulated environment, apply a rule, and change its simulated state. Builds confidence before tackling real IoT stuff.
These examples really clarify things. Now, AI agent applications also suggest some specific project ideas for beginners,
Yeah.
right? Especially for e-commerce.
Yes, it lays out a few good ones. First, that price monitoring agent we discussed,
Yeah.
tracking specific products online, alerting you to drops.
And why is that beginner-friendly again?
Consistent website structure for price info, usually. Simple logic, just compare current price to target price. No complex machine learning. You could use Python's requests and beautiful soup libraries, store URLs in a simple file, and maybe use an email library to send alerts.
That sounds genuinely useful, actually. What's another?
A basic content-based recommendation agent. It suggests items based on shared tags or keywords.
How does that work?
If you're looking at, say, hiking boots, it finds other products tagged with hiking or outdoor gear. It avoids complex stuff like figuring out why people buy things together, just simple metadata matching.
Okay.
You'd represent products by their tags, find others with overlapping tags when one is viewed, maybe use a simple score to rank them.
A simplified version of Amazon's People Also Bought.
Kind of, yeah, but much simpler logic based just on the item's description tags. What's the third idea?
The book suggests a keyword-driven news aggregator. You give it keywords like AI ethics or renewable energy, and it fetches relevant articles from news sites or RSS feeds.
How is that simple? RSS feeds are often well-structured, XML, making them easy to parse. The core task is just matching keywords and titles or summaries. Python has libraries like feed parser that make fetching RSS easy. Then you just display the matches.
These all sound like great starting points. So if someone wants to build one, what tools and approaches does AI agent applications recommend?
Well, first, it emphasizes a structured approach, even for simple agents. Using the PEAS framework,
Yes.
performance, environment, actuators, sensors, define these upfront. How do you measure success? Performance. Where does it operate? Environment. How does it act? Actuators. How does it get info? Sensors.
So plan it out first.
Exactly. Even for a simple price tracker. Performance is maybe finding price drops quickly. Environment is the specific websites. Actuators are email alerts. Sensors are the web scraping part. Defining P's keeps you focused.
Good discipline. What about the actual building?
Start simple. Rule-based systems. Those explicit if-then rules. They're easy to grasp, easy to write, easy to debug. Get comfortable with translating logic into rules before worrying about machine learning.
Makes sense. Specific tools, programming languages.
AI agent applications leans towards Python. It's readable, great community, lots of helpful libraries.
Which libraries are good for beginners?
It suggests NLTK for basic text stuff like simple chatbots, Reeve for regular expressions, powerful for finding patterns in text, requests for getting web pages or API data, beautiful soup for pulling info out of HTML.
Okay.
It also mentions Dolce as an easier way to play with large language model ideas without needing massive resources, and scikit-learn if you eventually want to try very simple machine learning algorithms, but only after mastering rules. Python lets you start simple and scale up.
What about non-coders? You mentioned those platforms.
Right, the book introduces no-code, low-code options too. Tools like MindStudio, Crew AI, Microsoft's AutoGen Studio, Google's Dialogflow, and platforms using things like LangChain often have visual interfaces like Langflow or Flowwise AI. You can connect pre-built blocks. Great for prototyping fast and understanding the agent structure, triggers, data sources, actions, decisions, even if customization might be limited later.
So, options for everyone. Does the book mention any core concepts or algorithms worth knowing?
It touches on a few fundamentals that are useful background. Pattern matching is key for text and rules. Basic search algorithms like breadth-first or depth-first search can be relevant for simple planning or game AI.
Like the tic-tac-toe example.
Exactly, which uses the Minimax algorithm. And understanding state machines, how an agent can be in different states or modes, can be helpful for managing conversations or operational stages.
Okay, good pointers. Any final best practices from AI agent applications for new developers?
Two big ones. First, keep your initial projects tightly focused, narrow scope.
Why is that so important?
Easier to define Ps, simpler logic, easier testing, faster to get something working. That quick win is huge for motivation and learning. Better a small, finished project than a huge, unfinished one.
Totally agree. What's the second practice?
Iterative development and frequent testing. Build in small chunks. Test each chunk. Get feedback. Refine.
Don't try to build the whole thing at once.
Exactly. It makes debugging way easier. You catch problems early, you can adjust course if needed, build a basic greeting for your chatbot first, test it, then add the next capability.
Build, test, refine, solid advice. Anything on the ethical side.
Yes, even for simple agents, the book says to think about basics. Bias. If your rules are based on biased assumptions, the agent will be biased.
Right.
Information accuracy. If your agent provides info like news or health tips, consider how to avoid spreading false stuff. Maybe add disclaimers.
Privacy.
Definitely. If it handles any personal data, even just keywords, think about how it's stored and protected.
And responsibility.
Yeah. What happens if it makes a mistake? Even simple agents can have consequences. Just worth keeping in mind from the start.
Okay, this has been incredibly insightful. We've really unpacked the world of simple AI agents, drawing heavily from AI agent applications, which, again, sounds like a fantastic resource available on Amazon for anyone interested.
Yeah, we've looked at what easy to develop means, their core components, seen some real examples, got project ideas, talked tools, and touched on best practices and ethics. Hopefully everyone listening has a clearer picture now.
And really, the invitation is there to explore this further, maybe even try building something simple yourself using these ideas.
Mm,
AI agent applications on Amazon seems like the perfect starting point for that deeper dive.
absolutely. And maybe a final thought to leave you with. These simple agents, even just following basic rules, they really demonstrate the fundamental principles of automation, maybe even a tiny spark of intelligence. Understanding them, how they sense, decide, and act is the first real step to grasping the bigger picture of AI, its power, its potential, and its implications. So maybe ask yourself, is there some simple, repetitive task in your life or work that a
Mhm.
basic rule-based agent could potentially tackle? It's a fascinating starting point for exploring this whole world.